Hey guys, I wanted to make a quick video going over this boat I've been working on for my engineering class. Every year UCF, the school I go to, hosts a boat race in the fountain in the middle of the campus. It's called the Reflection Pond, and the race is called the Great Naval Race. And essentially the goal is to carry an orange out and around the fountain and then back. It's shaped basically like a half circle with a fountain in the middle of it. So it's like a parabolic shape, trajectory, if you will. And it's basically whoever does it the fastest and transports the orange successfully wins. So most people that I've seen do this in videos in the past and in person have used either soda bottles or water bottles or pool noodles, really any kind of like cheap little thing they can think of just to whip together a raft. I don't know if that's just because they see other people do it and they figure it's a good idea, or if it's because it's easy to work with or what. But literally almost everyone I've seen has that structure to their boat. Well, I actually wanted to build a boat because, well, quite frankly, I've never built a boat before, and I'm always interested in new things. So, went online and looked up several different designs on wood boat making, and settled on one that I ended up modifying for this particular application. So I'll go ahead and show you. So, this is my little idea board, if you will, and essentially what the boat looked like. It was supposed to be an 18-inch hull. If you'd like to look it up, it's if you search up 18-inch mono hull boat template, it'll probably pull up the form post. Anyway, the guy posted a bunch of little templates for the formers, which are these guys. I am wearing my robe. I just got out of the shower. This is the only time I have to really make a video. Anyway, so yes, these are the formers. And that's what gives you that profile. I had to modify that profile, indicated by that dotted line, because instead of using a prop, I actually decided to use a jet, which you can see there. So what that basically does is it sucks it in the bottom and then shoots out the back. It's basically an inboard propeller, just like how a jet ski works. So I had to modify those. I had to modify the bottom plates. A lot of sanding, a lot of filing, but I ended up getting it to work. And I'll probably post this in a reply to that form and put a link in the description so you can see the pictures from the build process. I don't really have time to edit together a video, so I'll probably just do that. But I basically started off with the formers, the stringers, the deck, and then I did the sides and then the bottom. And followed my template, or my little design here, pretty well. I wasn't really sure on the size of everything, but it seemed to work out perfectly, actually. So I knew I wanted to use 2 batteries. Initially I was going to use those in series to get a total of 14.4 volts, plus or minus a bit, because these batteries do hold a little bit more charge than that. But I was originally going to overvolt the little motor that came with this jet. And I'll show you that motor now. So I have my little goodie box here. So this is the motor that came with the jet. If you type in NQD RC jet, it'll pull this up. It's a little plastic jet, and then it comes with this little motor mounted on it typically. So I went ahead and ripped that off, and I had this motor. I've had this motor for probably 10 years, since middle school. I traded a couple switches with some kid for this motor. I believe it was for an RC car, but it's the most powerful motor I had on hand, even more powerful than those. But this thing draws a lot of current, probably in the neighborhood of 30 amps. So I decided to, instead of overvolting it, hook these up in parallel so we have extra power and runtime if need be. To control that, I am using this little guy. This is from the Bobot kit, the basic stamp. And that is doing a couple things. It is controlling the servo there, which is also from the basic stamp kit. And that controls the rudder. It's not really a rudder, it's more of a jet nozzle that controls that. So essentially what I want it to do is go in the water, turn on the motor, go straight, turn, continue straight, and then turn again. So it'll essentially go in a square. And I can adjust those timings, which I'm planning on doing tomorrow and Thursday. The night before the race, they say the reflection pond you're really not supposed to go in. Like there's some fine or something if you do it. But apparently everyone for this race goes in the night before they test their boat. So I'm counting on that to finalize the timings of everything. I mean, it's pretty big. There's plenty of tolerance for the timings, but I'd still like to do a couple dry runs, so, or wet runs, more like it. So I actually had to do quite a bit of research to control this motor with this small board. Initially, I was just going to use a solid-state relay, but this board is only capable of outputting 20 amps, or 20 milliamps, which isn't much. It's not nearly enough to activate most relay coils, so I was recommended by some people in the Engineering Innovation Center to use this. This is it's actually the one I had in there. This is a BUZ 10. This is a MOSFET, and it's rated for, I believe, 20 amps continuous, 90 peak. So I actually had this mounted in there. But the problem is, let me see if I have my paper here. Yeah, I do. So here's the little circuit I had right there. This is it. The problem is, since I only am able to put 5 volts in, which is right about here, that only equates to between 10 and 12 amps. So that was not enough to actually start the motor. So that gives you an idea of how much current this motor draws. So I was going to do a transistor circuit to bump that up to 7.2 volts, which is the maximum voltage of the 2 batteries, the way I have it configured. And that would give me somewhere in the range of 30 amps. I did that, I tested it, still wasn't giving me the full punch that the motor was capable of, and the current that the batteries are capable of providing. So I went to this really cool store here in Orlando called Skycraft. If you are in the local area, I highly recommend going. If not, they actually have a Google Maps like tour, street view inside of it. Really cool place. I'd recommend checking it out. Anyway, I got this 40 amp solid state relay. Monster thing. It's probably $100 part. I got it for 15 bucks. So slap that in there. Got some 10 gauge wire going to the motor. Because this actually was melting my alligator clips, so I got some heavy 10 gauge wire, and this thing just absolutely hauls. I'm not going to do a test for you right now. I can. Let me grab my phone here. I got a little video of it on there. Let's see. There we go. I apologize for the crudeness of this video, but here we go. So this is me testing it. So you can get an idea how much power that is, and that's about 2 feet of room there between the back of the boat and that cabinet, or not cabinet, Tupperware container. So plenty of power. This thing's absolutely gonna fly. So tomorrow I'm gonna bring this to a pool. There's a friend I know that lives off campus that has a pool in his community. So we're going to go there and test it out, and just to get an idea of speed and whatnot, and then probably might get some video of that. And then Thursday night we're going to go to the reflection pond where the race actually takes place, test it out, finalize the code for the basic stamp, get the turning down right, and then the competition's Friday at noon. So I'll definitely have someone film. I think my friend Chris is going. So I'll give him the camera. He can film for me because I'm going to be out there running around trying to get this thing. So yeah, so that's something to look forward to. I hope you guys enjoyed this video. I'm having fun with this project, so I will definitely keep you updated. Let me just do a quick little, let me pick this up and show you guys. the like underside and whatnot. Oh, and I never really showed you how it worked either. So there's where it takes in the water. And of course, that's where it shoots it out. Weird camera angle. And then I'll turn it on for you. I actually unplug the control wire for the motor because that's super loud. I mean, it sounds like a vacuum cleaner practically. So turn it on. A little code centers the servo and does a quick little test. So there you go. It's centered. And then normally when I press this, the buzzer comes on, then the motor comes on, then it starts the turn sequence. Since I've unplugged the relay, the motor won't come on, it'll just do the turn, so I'll show you that. So right now the motor would be on, turns once, and then it'll turn again, keep the motor on for a second, and then the motor would turn off. And that's it. So I have to figure out I have to get two timings down. I have to get the timing for the turn to start, and I need to get the timing for like how long this is actually turned for. Because I have a feeling this thing's going to turn on an absolute dime. So anyway, updates to come. I'll let you guys know how we do in the competition. Anyway, thank you for watching. Catch you next time.